Okay, so we have our CoreOS cluster running, and we can now use Fleet to run multiple copies of our web apps. And this brings us to kind of the biggest difficulty that a lot of developers have when moving to a services/microservices architecture is, oh my goodness, this IP address for Web 2 could change. If this machine dies, Fleet is going to reschedule Web 2 over here. So now Web 2 has a brand new IP address and a brand new port. So how do I handle that? And we basically need to bring in service discovery. It's really two phases to be solved: is service registration. So etcd is basically going to be our hub, the internal etcd. It's going to be our hub. We're going to register that these services exist and are running. And then Nginx, our load balancer, is going to query etcd and discover those services and kind of watch that for changes. So whenever services arrive or depart, Nginx is going to reload its configuration and restart itself. And so let's handle that first step of service registration. To do that, CoreOS gives us a great tool called Flannel. And you see in the cloud config file, we've started Flannel here. And what Flannel is going to do is it's going to give a unique IP address to every single Docker container that runs. And it's going to be an internal IP address, like a 10.0.IP address. So it's only accessible to services running in this CoreOS cluster. It's not going to be accessible outside, which also solves another cool problem for us. When some app runs, we don't have to expose any public ports anymore. We only have to expose internal ports to my Docker container. So right now, our some app at service is doing an uppercase P, which says, hey, expose all the ports that my node sample app is exposing, and create a dynamic port for them that's accessible publicly. Let's kind of just go through this real quick. I can list units. I have nothing running. So let's go ahead and start some app at 1 through 4. So let's get 4 copies of some app running here. Okay, great. Still got those error messages. I need to look into what those are. So fleets, control, list units. Great, I've got 4 of them running on 4 different machines. And so let's go ahead and SSH into this guy. Have that handle it for me. And I'll do a Docker PS. So that's automatically, it's exposing port 3000, which is getting mapped to 32770 externally. That is available to anyone that has access to this CoreOS cluster, which, if you remember, on DigitalOcean is everybody in the world, because these are all public. Of course, you can fix that with IP tables, but a cool thing is using Flannel, we're not even going to have to do that anymore. But let me show you real quick. So if I were to kill this node, let's say I were to go to DigitalOcean and just send the power off signal to this machine, anything running on that machine, Flannel would reassign to another machine really quickly, pretty much as soon as it noticed that that service died. But then they'd have a new IP address, and they'd certainly have a new Docker port as well. So what Flannel does is Flannel actually assigned this guy an internal IP address. So let me go ahead and grab that out. Let's go docker exec some app 1. I'm going to run a command within some app 1. And I'm just going to run IP address list. So you can see if I look at my Ethernet 0, I've got this IP address that has been given to me. So now I can just ping this port 3000. Actually, I'll just ping it. Yep, it's working. And then let me go to a different machine. And let's see, fleet control list units. I'm going to go to a completely different machine, a completely different container. Some app at 3. And let's get into that app. Let's go docker exec IT. I want to do an interactive terminal, and we're going to go into some app 4. So I'm going to open up a bash terminal basically within my some app 4 container. Whoop. Did I do the wrong one? Yep, I did at 3. So some app 3 is the container that's running on this machine. Okay, there we go. Now I'm in some app 3. Now let's do a curl. Let's actually curl this IP address, port 3000, because we don't even care about an externally exposed IP address. And there you go. I've got my HTML document from my other web service running on my other container. The two things that are great about Flannel is, one, we don't have to use Docker link at all. So if you're familiar with Docker link, you can link two containers together and it'll set a bunch of environment variables that tell you all how to talk to them. But now we don't even have to worry about that. We just have to register each web service with its accessible IP, and the port is always going to be 3000 on any of our web containers. So how do we actually register this? Come on, let's get to the meat and potatoes here. Let me get out of here. So there's basically two ways to register this. One, we are going to register this to etcd internally. So we're going to use etcd control, and we're just going to set a key. And then other services can get a key or they can watch it. So the two ways of doing this is you can either have your some app service actually handle this. So in this case, I'm running a Node.js application. That Node.js application could automatically register its IP address and port 3000 to etcd. All I have to do is kind of give it, I just have to mount the etcd control as a volume within the container. But it's not really the best practice for a service to handle its own registration. What you want to do instead is a sidekick service. So we're going to create a some app discovery service, and this will kind of link to every instance of a web service, and then it will run alongside and it can monitor the service for us. And when the service goes up or down, we're going to either add or remove a key from etcd. So here's what that file looks like. It's got a description. We're going to announce some app 1. We're going to bind to some app 1. And then we're going to start up after some app 1 has started. And then we have this fleet configuration here, which says it's a machine of some app 1. So that means whenever we stop some app 1, then it's automatically going to start and stop some app discovery at 1. So that means basically once we've kind of loaded up this service, we don't have to manually control it anymore. It will automatically be a slave of some app 1. So here's what that's doing. If you're good at bash script, you're going to see that it's basically just going to run a loop. Every 45 seconds, it's going to run etcd control, set this key right here, services some app upstream, some app 1, and it's going to run this docker inspect command and get the IP address of some app 1. I'll show you that command real quick. Let's do that SSH again. So I can just run docker inspect. We're going to get the network settings and IP address from some app 3. There's the IP address. So it's just going to get that IP address, add port 3000 to it, and then it's going to give it a timeout of 60 seconds. So this key is going to expire after 60 seconds, but we're going to heartbeat update this thing every 45 seconds. And then if this service ever stops, then we're going to remove that key from etcd. Okay, simple enough. Let's go ahead and submit this. Some app discovery. So we're submitting this to fleet control, and then let's go ahead and start 4 copies of it. So we do have to kind of create these either by doing a fleet control start or a fleet control load. Let me show you what just happened too. If I go fleet control, list unit files, we only submitted 1 unit file, and that was the discovery at file. And whenever you create a new number from an at file, then what it does is it actually clones that file so you have a copy of it. So these copies did not exist until I ran fleet control load or fleet control start. If I had not run those, there'd be no companion services, there'd be no sidekicks for these. All there would be is a sidekick for this guy right here, which we never actually run. So I had to do a run or a start to create those sidekick files. And from now on, whenever I do a some at 1 service start or stop, then it will automatically start or stop its companion as well. And if you'll notice, the companion service also got loaded on the exact same machine. So sidekick 1 got put on the same IP address as some app 1. Sidekick 2 got put on the same IP as some app 2, and so and so. So basically they're linked. As far as fleet is concerned, this service and this service are coupled together. So let's go do fleet control list units. We've got them running. So they're all running. Let's go ahead and SSH in and see what etcd looks like. So etcd ls recursive. So these are all my etcd keys, and you'll see that it has now created a services folder with some app in it, upstream, and we've got 4 upstreams that are set. Let's go ahead and look at one of these. There we go. So that's an IP address for some app 3, some app 2, some app 1, and some app 4. So now we can spin up an Nginx instance that watches this folder right here, and when anything changes, it reloads itself. Hopefully you got this. This is the one, again, this is the most complicated piece. Understanding service registration to me is the toughest part. Service discovery is a lot easier than service registration. So let's go ahead and move on to service discovery and Nginx.